Okay, welcome to the 8th virtual office hours for the 2014 POSA MOOC. What we'll be talking about today will be going over the skeletons for week 8, assignment number 7, and I'll also be showing another example of how to implement a AIDL and bound service, a couple of bound services actually, using both synchronous and asynchronous approaches. And naturally, I'll also be using this time to answer any questions people have about anything else that we've covered. We'll definitely go through the list of questions that were posted to the virtual office hours website subforum for week number 8. Jules White cannot be with us today, but he has recorded a video of him going through the solution to week 7, assignment number 6, and he'll be posting that shortly, at which point people who have questions about that can post them to the appropriate subforum on the discussion boards, and we will have Jules answer any questions you may have about that, since that's the current set of grading that we're doing right now. Okay, so why don't we go ahead and begin. Looks like we got a bunch of people online, which is great. I see a few questions popping up, so I'll address those as soon as I've had a chance to go through the skeletons for this next assignment, week 8, assignment number 7. But first, let me go ahead and bring up the Emacs editor, which should be here in just a second. All right, I think that hopefully is working. So here then is the source code for the skeletons. So let's go ahead and talk about this. So as before, we have a download activity. This skeleton from the activity side is similar to the one that we used from week 6, assignment number 5. Basically, it prompts you to enter in a URL, and then it goes ahead and it downloads the image in a service and passes it back to the activity. Once again, we divide up the activity into 2 parts. We have the download activity, which is where we do most of the work having to do with communication, and then we also have download base, which is where we do things that relate to basically user interface displays and prompting the user and so on. Real quickly, you can see here we've got the edit text, which we use to get the URL from the user. We have the image view, where we're going to store the output. We have a couple of default bitmaps. We have a function that's used to hide the keyboard after you enter the URL. Here's the display bitmap method. As you can see, all this does is it takes the string that's passed from the service back to the activity, and it decodes the file corresponding to that string, turns it into a bitmap, and then it goes ahead and makes that the image that's displayed in the image view. Here's reset image, and then finally we've got the onCreate method, which is called, of course, when the download activity starts, and it just sets up the view, the content view, and it goes and locates various widgets by looking them up by their IDs. And then we go ahead and turn off strict mode. This isn't actually strictly necessary, and I'll talk about that when I show the skeleton for how you would implement the synchronous downloads. Turns out there's a couple of different ways to do that, and if you do it one of the ways, you don't need to turn off the thread policy on the client side. The reason we had this here originally was because by default we were having the main thread block, which is not a good idea, but there's a better way to do that I'll talk about here in a second. All right, so here's the activity itself that's doing the bulk of the work. We have this thing that's called download call and download request. We'll go and look at those in just a second. These, of course, are the proxies that these are actually the object references to the references to the services, the synchronous and asynchronous service, to the objects that reside in there, inside those services. And these, of course, are generated automatically by the AIDL compiler when it reads the various interfaces. Let's go ahead and take a look at those interfaces real quick. Here is the download call interface. The download call interface is a interface with a single two-way method called download image, and as you can see, you give the URI of the image, and then it goes ahead and will make a remote two-way call, where remote means to the service that's running in a different process, And as we'll see in a minute when we look at the implementation of the service, the implementation of this particular object will run in a background thread in the service, download the image, put it into a local file, and then return a string which contains the path name of the file. So that's basically what download call does. That's a two-way call. Download request is a little different. This is used for asynchronous communication with a service, and what it does is it splits up the request for download with the response that is sent back. So this means that the client code will actually not block in the activity, won't block the UI thread at all. What we do here is we have a one-way method called download image. You pass the URI just like you did for the two-way version, except you also pass a callback object, and the callback object itself is a reference to an object that's defined using AIDL, and that's then used to receive the callback, and we'll see how that works in a second. Here's what the callback method looks like, or the callback interface looks like. Download callback is an interface, and it has a single method, which is also a one-way method, which means it won't block the caller, and that goes ahead and takes the file path as a string, and it sends it back from the service to the activity. So you can see we're getting asynchrony here by splitting the interfaces up into two parts, one for the invocation, which is a one-way where you pass in an object reference to an object that's defined back in the activity, and one for the response, which sends the results back by having the service invoke a one-way method to send the path back to the activity. All right, so those are basically the AIDL files. This particular example doesn't really illustrate it, but you can have arbitrary types that are used in these interfaces, and I'll show you some other examples of that later. Passing around strings isn't really all that interesting at some level, because you could do basically the same thing by just using a message and a messenger. But when we start getting more sophisticated types, it becomes more worthwhile. So these then, download call and download request, are basically the object references to those objects we just looked at defined in IDL or AIDL. Here is the service connection callback object. As you can see here, we're going to have two of these, one for the synchronous communication, one for the asynchronous communication. They're essentially the same, just different in terms of the details of which interface is assigned, and that's why for general purpose use we define something called a generic service connection, which I'll show you later. We don't use that for this particular assignment, but you could if you wanted to. As you can see here, we have the onServiceConnected hook method. This is called back automatically by Android and its binder framework, which basically is implementing the broker pattern. And when this is called back, it's called back after a service is connected, and it takes the binder object returned by the onBind method in the service, which is a factory method, and it passes it back here. This is basically a hook method, which is also to some extent used as a factory method, and it takes the service that comes back and it goes ahead and will essentially convert this thing into an interface by taking the iBinder parameter, which is called service, and then essentially converting it into a download call reference. And it uses the stub method to do this, and it basically says stub as interface to do the conversion. So that's one of the things you have to fill in. Here's on service disconnected. This basically just sets the download call member to null. Here is the async version of this thing. As you can see, the logic is essentially the same. The only difference, of course, being that this deals with a download request reference as opposed to a download call reference. And once again, you do basically the same thing here, so you can fill it in as per the to-do comment. And then the download request on service disconnected just nulls out the download request. Here now is the download callback stub that you have to implement on the activity side, on the client side, in order to be able to receive callbacks from the service. And so when the service is finished when the asynchronous version of the service is finished downloading the file into a local file, it extracts the file name, and it goes ahead and invokes the send path on the download callback. It was passed as a parameter, and as you can imagine here, it's just going to go ahead and display the results. And you'll have to do this in a way that gets the results back to the user interface thread. But that's easy because you simply have to use the run on UI thread method to do that. Here's the run service method itself. Some work that you have to do here. If the user clicks the synchronous button, then you have to go ahead and bind to the service, passing in the appropriate service connection and the intent that you need to locate the service. And of course, you get that by using the make intent factory method that's defined on the appropriate service. And you do essentially the same thing for the async version here. Now, here's where it gets interesting. If you're so inclined, you can certainly implement this to do a two-way call here directly in the run service method. Although, strictly speaking, that's not the best thing to do. We even make this work at all by disabling the policy that prevents this from blocking back in the download base class. But a much better thing to do is to go ahead and use an async task or a thread and a runnable to go ahead and create a thread or start a task, execute a task, and then run the request to do the two-way call in the background, and then take the result and go ahead and display it. And when we do virtual office hours next week, when I show the final solution for all this stuff, I will illustrate how I used an async task to do this. It's really easy. It's just a couple lines of code, and it allows us to run the two-way call in a background thread, and then when it's done, we go ahead and display it back using the user interface thread, either with an on-post execute method or by doing run on user interface thread, run on the UI thread. Either one of those things works. For the async case, it's a little easier because the call is just a one-way call, so it doesn't block. So you'll end up getting the results back via the callback we looked at up here. Note, by the way, that when this callback is invoked, because it's using AIDL, that will go ahead and run in a pool of threads. It'll run in a thread from a pool of threads that's provided by the binder framework to the activity. And so that's why you have to make sure that you take the result and get it back to the user interface thread so it can be displayed. Here's the onStart method. As you can see here, this goes ahead and binds to the service, doing those various calls we were talking about before. So it's going to be called whenever things occur. So notice that the bind service stuff is done in onStart when the activity is becoming visible, and that means that all you really have to do up here are just go ahead and invoke the method calls that will do the various AIDL method implications, either it's two-way calls or one-way calls. The actual binding of the service and the creation of the intents and the passing of the service connection is done here in onStart. And you'll see down here in onStop, it goes ahead and unbinds. And the reason for doing this, of course, is to allow the service to clean itself up if nobody's bound to it. And here's a couple of accessor methods that we use for testing purposes by the test scripts. Okay, so that's download activity. Let's go ahead now and take a look at the skeletons for download for the services, for the bound service async and the download bound service sync. Let's look at sync first. So this is a service, which means it's going to be a background activity, or background, not activity, background computation. Here we have the download call implementation, which is going to allocate a stub, and that will go ahead and have a download image hook method that's called. And all you have to do there, of course, is call the appropriate method in download utils to do the right work, and that will block synchronously until the call is done, and then it returns the string back to the activity. Notice in this particular case that this method will always run in a separate thread in a pool of threads that's managed by the binder framework, so you don't have to worry about multi-threading. That's one of the nice things that comes kind of for free when you use AIDL in the binder, is that the dispatching takes place automatically for you in a separate thread from a pool of threads that's managed by the binder. So this method is really short and concise. Here's the onBind method. All this thing does is simply return. It's a factory method that returns the download call implementation, which is defined up here, as you can see, as a download call stub. And that just gets returned. And then the make intent method is where you have to do the logic to make an intent that can be used to start the download bound service sync, and that should be pretty straightforward to do. All right, so that's the service. It's a synchronous call, as you can see here, and all the plumbing and threading and so on is handled for you, which is one of the reasons why we would use AIDL, because all this stuff is handled for us automatically. Here's the async version of this. It actually looks very similar in a lot of ways. It's got a onBind factory method that returns the appropriate binder object. You have to fill in the make intent method. And here then is the download request implementation. And it's a download request stub. And what you're going to do here is you're going to take the URI that's passed in, you're going to call down to the download utils method to download the file, and then you're going to use the callback object in order to call the send path method to send this back to the client. Now, this particular example has the callback run in the same thread that does the downloading, and in some ways that code is almost identical in terms of service side behavior to what's done with the synchronous version of all this stuff. But there's no necessary reason why this has to be the case. You could go ahead, if you were so inclined, and you could queue up the callback, and you could have that thing run by some other thread in the background if you wanted to. And there are various reasons why you might want to do that. One reason why you might want to do that is the fact that there's only a limited number of threads that are actually in the thread pool that's managed by the binder. I want to say the number is like 16. We'd have to look up and see where this setting is done. But there's not an infinite number of threads in that pool. So if there were lots and lots and lots of client requests coming in, you might not actually want to block the calling thread for the duration of the call, because you could run out of threads. And so in that particular case, you might actually queue this thing up and then run it out of a separate thread pool, so you wouldn't end up blocking this thread for any length of time. So there's all kinds of other variations, and that's one of the nice things about having a callback object, is you can decouple the time and space when the callback is done to send the result back to the caller. All right, so that's basically the download service async version. And then here's download utils. This is just a slight variant of the one we had before. You have a download file method, which has an offline and an online version. Once again, we have a get temporary file method, which for this particular case is going to create the same file each time for every image you download. It'll just basically use the name of the image. The name of the URL is the name of the image, so it'll always put it in the same place. But in real life, you might want to replace that with something that gives you a unique file each time, because that'll work in real life. This is just for testing purposes. So basically, this just has a helper method called download file, and that's what's going to be called by the various async or synchronous services to do the job. So that's basically an overview of how this works, and let's go ahead and see if there's any questions that people have. All right, question number 1 from Silvio. Wants to know what's the best way to get the path name to be used to display the downloaded image in the UI thread. So the best way, I think, there is probably to create a runnable that has basically a closure, and in the closure it'll go ahead and do the display results or display image call, and then just go ahead and pass that via run on UI thread. That's by far the simplest thing to do. Which parts, oh, good question. Which parts of the solution are parts of the broker pattern? Well, let's go back and look at this. Oh, by the way, I will give you a quick answer to the question now, but if you want to see a very, very detailed analysis of what takes place inside the Android middleware, go ahead and take a look at the broker pattern videos and the proxy pattern videos from this week's set of optional videos. I think it's week number 9, and you'll see that there's 4 videos, 2 for the proxy pattern, 2 for the broker pattern, and they basically walk through in great detail and map everything from the Android binder and AIDL mechanisms onto the broker pattern. So I'll just outline it here, but if you're really interested in this, you probably want to go ahead and watch those videos because they'll go through it in a lot more detail. So let's take a look and see some of the things that correspond to what's part of the pattern. So obviously, part of the pattern is defining interfaces. So these are the interfaces, of course, and then those interfaces are run through the AIDL compiler automatically if you're using Eclipse. And what happens then is we get basically proxies and stubs that are generated. And so you can see over here, we don't actually have this code, of course, because this code is what you have to write. But if you were to look here, you would see that you would be making an invocation on the M download call and M download request proxies. And those proxies are, of course, automatically generated. So that's how the client invokes the method through the proxy. The proxy is actually initialized by the code that you have to write here. This code is what's called back automatically by the on-service connected methods, which, of course, are part of the broker pattern. Part of the broker pattern implementation in Android involves exposing the way in which callbacks take place to give you back the proxy objects, and that's done through this very stylized model. And if you take a look at some of the examples and you watch the videos, it shows how all that stuff works. If you watch the videos that are the optional videos for week 8, it'll show you how this stuff all works. Things involving implementing AIDL interfaces. And so that's how the proxies get set up. The on-service connected and on-service disconnected hook methods are part of the broker implementation of the binder framework, and that's that's just a particular Android quirk of the broker implementation. I'll talk more about that a little bit later when we go through the list of questions from the Virtual Office Hours website, because someone asked a question about that. So that's basically the client side. The client side is just getting a hold of those proxies and then invoking method calls on the proxies. And if you watch the proxy pattern videos, it'll show how those proxies that are generated convert the method call parameters into parcels, and then those parcels are sent through the binder framework, which is really the guts of the broker pattern implementation, and it shows how they're sent over to the service side of the house. So if we go over here, take a look at, say, the sync service, then this is a stub, which is part of the proxy pattern implementation. Actually, it's the adapter pattern, but it's basically part of the broker pattern implementation. And the stub is what effectively glues together the application-defined behavior, which in this case is something that downloads images, from the generic transport mechanisms that is provided by the broker pattern. So if you take a look at the broker pattern implementation, you see that you have to have a way of getting connected to the broker implementation on the server side, and the generated stubs are what do that. And if you watch the videos, it shows how all this stuff works under the hood. But effectively, when all is said and done, this stub takes the parcels that come in from the activity side, from the client side, and it converts the contents of the parcel back into parameters, and then it invokes them on the download image callback method. And we'll take a look in just a second to see how this kind of works under the hood. So just a word of terminology. People use different terms for this stuff. If in the Corba implementation of the broker, you have stubs, which are the client-side proxies, and you have skeletons, which are the server-side adapters. Android uses slightly different terminology. In Android terminology, proxies are what are used on the client side, and stubs are what are used on the server side. But it's basically the same idea. I think the broker pattern may call these client-side stubs and server-side stubs or something along those lines. The terminology is not important. What is actually done is important. And so speaking of what is actually done, let's go see if we can find the generated code. So here's the generated code for this stuff. Let's go take a look at the generated code for the call method. This is the synchronous version. As you can see, this is an interface called download call. This is a Java interface called download call. This is what's automatically generated by the AIDL code. And the videos walk through all this stuff, so I'm not going to go through it in gory detail. But in effect, there's a stub that's automatically generated that implements the download call interface. And so that means it has a method that's going to be called download image in it. And then there's also the constructor for this thing, and you can see it goes ahead and it attaches itself to the broker binder implementation by something called attach interface. Here's the as interface method. This is a factory method that's used to take a binder and convert it into a download call reference. And you can see kind of how this works. There's some magic it uses internally using something that's called it's basically a component mechanism, component interface mechanism to be able to generate out the appropriate interface. And as you can see here, it takes the object that comes in and it turns it into a proxy. That's what's done on this line right here. And we'll go look at that in a second. Then there's also some stuff that's used internally to be able to convert things into binders and use to transfer them across the network. As you can see here, when it's a download image invocation, this goes ahead and this is what the stub is doing. When you get a download image call that comes in as a message, it goes ahead and it creates from the data that's the parameter from the parcel that was sent over, and then it goes ahead and it does the up call to the download image method. This is the message. This is the method that you fill in. It's an abstract method that you fill in, and that's what gets called back with the parameter. And you can see it takes the result as a string and it goes ahead and writes it back into the reply parcel, and then that's sent back to the client with the various method calls here. And let's see, here is the proxy. This is what's used on the client side. When you call the download image method on the client side, you can see it takes the URI, which is a Java type, and it turns it into a parcel. As you can see here, here's the transaction for this thing. It goes ahead and takes the data, and it takes the reply, and it does the transaction on this, and when the result comes back, it passes it back as a result, which is returned as the result of the proxy. And then here is the download image method. This is basically the abstract method that you have to override in the server part of things. So that's basically what the generated code looks like. You don't really have to know or care how that works. All you have to know how to do is override the appropriate hook method, which is the method that's called back by the stub when the request comes in from the client. And of course, you have to know how to call this stuff on the client side. So that's really all you have to know. All that generated code handles all the type conversions from native Java types into parcels that are actually passed back and forth via the binder framework, which is implementing the broker. Okay, so that's a quick kind of Cliff Notes version of what the broker's doing. But if you want to really see how it all works in much more detail, go ahead and watch the videos on the proxy and the broker, and it'll walk through all this stuff. Jet likes the comments. Yes, I agree. You can thank Mitchell Gordon for that. He's the one who wrote this, and then I went back through and just tweaked a few things, but he documented it very thoroughly so you could see how the different patterns were used. And obviously, you know, downloading images is only a marginally interesting application, but the patterns and the mechanisms we're looking at here are much more reusable and can be applied to many different kinds of things. Yes, there's an Android convention to use. Derek asked, is there an Android convention to use for onStart and onStop to bind and unbind to bound services? Derek, all you have to do is just go take a look at the discussion about AIDL, the web page that talks about AIDL and the binder, and it'll tell you exactly what to do. You basically do those things in onStop and onStart. That's just kind of the way it is designed to work. And if you read the website, the documentation from Android, it should explain to you why you do that. I think the reason is that on resume and on pause are a little bit more short-lived operations. Those are called when a window may still be visible but is blocked for a short period of time. For example, if a dialog box pops up, then the window is the display underneath it is temporarily paused, but it actually is about to come back in focus again because dialogues are meant to be very short-lived. So we don't do the bind and unbind in the pause and resume because those are meant to be very short-lived calls, just long enough to, you know, update something in a dialogue, like, yes, I do want to download this image or whatever. But it's only when the actual window becomes blocked, it becomes invisible, which is what happens when onStop gets called, or becomes visible, which is when onStart gets called, that we actually do the calls. But that's just classic Android lifecycle conventions, and if you read the documentation, it'll explain why. Sean asked, why do we turn off the strict mode? Again, I explained, Sean, a few minutes ago how to do this so you don't have to turn off strict mode. What you do is you simply use an async task or a thread. I like async task because it's really, really simple to do, just a few lines of code. And you basically spawn an async task, or you execute an async task, and then the async task do in background method goes ahead and does the two-way call on the mdownload call proxy. And when it's done, when the call is done, it returns the string as a result from doing background, and then the onPostExecute method is called, and that of course turns around and displays the image to the screen because it's running in the UI thread. So that's the way to do it. I'll show you an example of that here in a minute. Are there any technologies that can use the AIDL compiler to make web services calls? Paolo, it's my understanding that there's something called retrofit, and retrofit is a framework that basically will generate both the AIDL calls to services as well as the web services calls. So I'll show you some examples of how you would write this by hand. It's not very hard, but take a look at retrofit. That may be what you're looking for there. Mark asks, it's not thread safe because it always returns the same file. Yes, of course. This is just for testing purposes. If, as I mentioned before, if you're really doing this in production code, you would be returning a different file each time, and so that would be the easy solution there. Someone asked me in German, which basically I'm thinking has to do with pattern-oriented foosball team. I'm not quite sure, Philippe, since I don't read German, but I guess that's probably a World Cup reference. To avoid annoying large parts of the population of the MOOC, I won't make any comments about the World Cup. I know a lot of people probably are rather distraught about the result from yesterday, so I won't rub salt in anybody's wounds. David asked the question, I can no longer get to the class from the Coursera website since the class ended. Well, I think you can still get to the class, you just have to manually go to the class. It's always easy to get to the class just by typing in the actual link. Let me show you how to do that, because that's what I do all the time. Let's go ahead and find a browser that's open somehow, somewhere. Here we go. So you can always get to the class, of course, just by saying class.coursera.org/POSA-002, and you get right to the class, and just bookmark that. You can always find it. So it's not like the class has disappeared. It's just that from the purposes of Coursera, the class is officially, quote, over, because we're done with all the official lectures. We're still finishing up the assignments and peer grading, but it's easy to find it. By the way, we worked it into the grading scheme so that you don't have to complete all the assignments in order to be able to pass the class with distinction. So if for some reason you were unable to do the last assignment or two, but you have done all the other ones, should be no problem. So for people who had planned a vacation now, not a problem. As long as you did well on the other assignments, you should be fine. You should still be able to pass. All right, let's see. Can you please explain the run service correct way of implementation using a thread once again? So Arya, I will do something even better than that. I will show you another solution that does it. It's not for the download application, but it's instead for the acronym application. And I want to go through this anyway because I've made a bunch of improvements to it. So what I'm going to do next is switch back to my editor, and I will show you an implementation that will illustrate how to do this. And then, of course, all you have to do is go ahead and map that to your assignment. So let's go over here, and we'll kind of pop out of this stuff, go back up a little bit, and go to examples, go to acronym application. So here's the acronym application. I think I showed this before, but I've made a bunch of improvements to it, and I want to show you a couple of those improvements because they're kind of cool. So if you recall the acronym application, what it does is it's basically a bound service front end to a web service. And the web service basically lets you give it an acronym, and it downloads the long form of the acronym, basically all the expansions of the acronym, and it displays in the user interface all the different definitions of that acronym, the date when it was first defined, and the number of uses of the acronym. So that's basically what it provides. Here's the acronym activity. Nothing too exciting here. It has a way of being able to display a list of acronym data. We'll talk about acronym data in a second. Here is the acronym activity. This basically shows some cool things. This is very much like the download application in several ways, but it's also got some other cooler stuff. So let me show you kind of how it works. Here's the acronym results stub. This is what gets called back when an acronym has been downloaded and we want to get back a list of acronym data. And you can see here it just goes ahead and it creates a runnable to display the results, and it runs this thing on the UI thread. And of course it does this because the send results method is an AIDL method, so it runs in the background. This particular implementation is much cooler than the download application, because we use our generic service connection framework to totally hide how service connections are done. So all that callback code is kind of gobbled up into a generic service connection. We'll look at that in a second, but it's really cool and really clean. We just define two objects of that. Here's the expand async acronym callback method. And as you can see here, this is the one that does the async version. So what it does is if the acronym request reference is not null, and we do this by extracting that from the async service connection async data member, we get the interface from that. That's part of the generic service connection framework. We take the object reference and we go ahead and we call expand acronym, passing in the acronym results data member, which we'll use to get the results back. So that's basically a one-way call. Here then is that two-way call I was talking about. This is the synchronous form of this thing. So we go ahead and we grab the object reference, and now we create an async task, and the async task is going to take a string, which is the acronym, and it's going to basically also get the results back as a list of acronym data. And then here we go to run the doInBackground method. doInBackground, which runs in a background thread, calls expand acronym, which is a two-way call with the acronym that we passed in. And this can block because it's running in a background thread, so we didn't have to remove the strict mode and so on. And when the result comes back, it returns this as a list of acronym data, which is what it gets back from this call. And that invokes the onPostExecute method, which takes that list of acronym data and displays it. And of course, that runs in the main thread of control, so it can call display results. And as you can see here, all we do is we create an anonymous async task with these two methods defined, and then we go ahead and we execute it with the acronym that's passed in. So that's basically, you could follow an example very similar to that if you wanted to in your download application in the download activity to avoid having to set the strict mode policy and disable the strict mode policy. And here's the onStart method, which basically just binds everything, and the onStop method, which unbinds them. So that's basically how the acronym application works. Here are the interfaces. These are kind of cool. Here's the acronym call. This is the two-way method that takes an acronym and gives back a list of acronym data. Here is the acronym requests method, which is the one-way method that takes an acronym results, object reference, and a string. And here's the acronym results method, which basically takes a list of acronym data as the results. That's a one-way method called back from the service. You can see that this is very, very similar architecturally to the download application. Same basic patterns are being used. But here's the part that's kind of cool. So here's the acronym data. Acronym data is basically data that's going to be passed back and forth between the service and the activity. And acronym data is a Java object, and of course we have to tell the binder framework how to marshal and demarshal this object. And so we define it in an AIDL file as a parcelable, and then we have an acronym data implementation, which implements parseable, and we define several fields: a long form, which is a string, the frequency of usage, and the year that the acronym was added to the web services database of acronyms. And then we define some constructors that take in parcels and convert them into acronym data. We also have a constructor that takes the various constituent parts and turns them into acronym data. We have something that converts the acronym data back into a string. And then we also have some stuff that's used automatically by the binder framework to be able to create a parcel. So as you can see here at the right time, and if you read about the parcel framework and the parcelable mechanism that's used in the binder framework, it expects there to be a field called creator with methods that can create from a parcel. So given a parcel, it knows how to make an acronym data. So this is basically just sort of boilerplate code. You always do the same sort of thing with this stuff. So this is something you would write one time, and then that allows us to be able to pass acronym data back and forth in the AIDL calls as parameters. So for example, we're going to return a list of acronym data, and all that code is done one time. It's all nice and neat and boilerplated. Let's go now and take a look at the acronym service. This is kind of cool. So the acronym service, it's going to do some interesting things here. It's going to use something called an Android HTTP client. You'll see what that gets used for. And its onBind method returns an acronym call implementation. Its make intent method makes the right intent. And then here is the expand acronym method. That's the implementation of the AIDL interface. That's the acronym call interface. And as you can see here, it takes a string and it returns a list of acronym data. And what it's going to do, this basically just forwards to the acronym downloads util get results method. We're going to look at that in a second. So get results is what does all the work, and you give it the HTTP client object, and you give it the acronym, and it gives you back a list of acronym data, which we then return from the function. So very simple. At this point, you can see we've pushed all the web services stuff down into the acronym download utils method. Here is the acronym download utils method. This is kind of cool. Check out what it does. It basically implements something that's a response handler. And response handlers are things that are used along with the Android HTTP client object. And you'll see how that gets used in a second. Take a look down here. Here is the get results method. Get results takes in an HTTP client and a string, and it goes ahead and it creates a new HTTP GET request, which gives the URL of the acronym service plus the acronym. So here's the URL for the acronym service right here. That's the little magic you have to have in order to use the web service. And so we give it an acronym, and then we go ahead and we create a new JSON response handler, which is our response handler. And then we call the execute method on the Android HTTP client object. And execute is given a request, which of course is the GET request, and it's given a response handler. And the results of this execute method, because it's a generic method, will be to return whatever the parameters are that we use here. And what we're going to use, of course, is a list of acronym data. So execute is going to return a list of acronym data. So let's go take a look at the response handler. The response handler is basically sort of a factory method or a builder or a template method. It depends how you look at it, but it's basically a template method that's working as a factory, so I guess we'll call it a factory method. And as you can see here, the JSON response handler implements response handler, and it's going to return a list of acronym data, which is what we're going to get back from the web service, or we're going to convert from what we get back from the web service. This handler response method is called automatically by the Android HTTP client execute method after it gets back the results from the web service it contacted, and it gives it back as something that's called HTTP response. And what we do here is we make ourselves a new array list of acronym data, which we're going to use here, and then we go ahead and call the handler response method on a basic response handler, which is going to get us back something that we can parse. We then go ahead and convert this particular response, which is a string that contains all the data. We go ahead and create a tokenizer for it. And then we go ahead and we extract out of this tokenized data a JSON object, and we treat it as a JSON array, because that's the long form, comes back as an array of acronyms. And then we go ahead with the response we get back there, and we take each of these elements one at a time, and we can make a new acronym data for each of these things. So for the JSON object that we got back, for each of the elements that comes back in the JSON array, we're going to go ahead and create an acronym, long form, a frequency, and a since for each of the things that are used to define how often the acronyms appear and when they first appeared with that particular acronym expansion. And those things, as you can see here, get added one at a time into the results list. So what we're basically doing here is we're writing this factory method that takes JSON data that comes back as an array, and we're converting it one at a time. Because you can kind of think of this as the builder pattern, I suppose. We're converting this stuff one step at a time into acronym data, and we're adding it to the list of acronym data. And then when we're all done, we return that acronym data as the return value of a handle response. And that, of course, is going to come back here as the result of execute. And execute then returns that back to the caller. And the caller here, if you go over here, is the expand acronym method. It's a hook method. It's defined as a callback by the stub, and then it takes that and it sends it back. And in this particular case, it's passing it back across the address space back to the download activity. So the cool part about this, if you think about what we've just done here, we've localized everything related to processing web service encoded information into one place as a response handler that knows how to take JSON encoded web service results and convert them into Java data types, basically a list of acronym data. So that's all localized. That's the one and only place that goes. And then we also used the AIDL definition to define methods that work with lists of acronym data. So those can pass things back and forth across process address spaces. And so we had to write the conversion method for JSON to Java encoding in one place. And then we write the encoding to be able to move things between processes in one place. And that code would probably be written by some kind of infrastructure developer. And then the great part is that the rest of our application logic, both on the server side with the service implementation, as well as the client side with the activity implementation, it doesn't have to know, doesn't have to care about any of that encoding. So the application code knows nothing whatsoever about web service encoded information. The activity and the service don't have to know about how to move things back and forth across address spaces in Android. Those are all shielded from the application developers. They just basically write what looks like Java code, and everything else is taken care of for them under the hood, which is very powerful. Now, I should also hasten to add that in real life, you would probably do something a lot more interesting than we're doing here, right? So what we're doing here is we're just basically making this service kind of be a front end to the web service, and then we're packaging it up as some shared logic that multiple applications can access. And while that's kind of cool, it doesn't really reveal the true power and benefits of a service. What we probably would do in real life is something like the following. We might write a more interesting service that did a lot more powerful stuff, or to keep with the acronym theme, we might have an acronym service that would actually go out and query multiple acronym web services. So if you gave an acronym, it might go look at 5 or 6 different acronym servers, get back acronym expansions from each of them, and then fuse them together, removing duplicates and so on, in order to give you a more comprehensive set of acronyms. And of course, you know, nobody is going to write a product to do acronym lookups, but replace acronyms with looking for the cheapest hotel, or trying to find you the best stock market value or price in a collection of market exchanges. Whatever it is, you would write a service that on the back end would run in a pool of threads and invoke operations to access web content through web service interfaces, and then it would coalesce the data, put it into a content provider, put it into a file system, put it into a database, whatever, and then it would get that information back to the applications. And it could even run in the background and be doing this stuff on your behalf as a cache, so that when you went to the service, it would only have to give you the results locally. So you could really speed things up if you made the service smart enough to be doing synchronization operations, say with a sync adapter or something else. So this very simple example just illustrates some of the key patterns of using a service. But in real life, you would have it do a lot more interesting stuff. Okay, so let's see if there's any questions. Hopefully that answered the earlier question about how you would write run service in order to be able to access the image information without having to block the main thread of control. Let's see. Kale asked the question, do you have any plans on producing a MOOC entirely focused on patterns? Well, if you go back and you take a look at the POSA 1 material, you'll find that there's a MOOC that basically does that. Let's go ahead and go over here for a second, and I will show you what I'm talking about. So let's go to the class website. Whoops. So if you go and you type in class.coursera.org/POSA-001, you will find all the material from the first offering of the POSA MOOC. And you may have to register, but you should be able to register and then access this material. And what you'll find here is about 18 hours worth of material focusing almost entirely on patterns and frameworks. It's got basically a complete case study of many Gang of Four patterns, which you can watch, a bunch of the Gang of Four patterns, all the classics like bridge and adapter and composite and visitor and iterator and so on. They're all covered here. About 4 hours worth of stuff there. There's a big discussion in section 2 going over patterns and pattern relationships, pattern compounds, pattern sequences, pattern languages, pattern complements, etc., etc. There's a discussion of frameworks and how frameworks and patterns relate to each other. And there's about 4 hours or so material there. Then in section 3, there's 4 or 5 hours worth of stuff walking through many of the patterns in the POSA 2 book, showing how you could build a web server using patterns. So lots and lots and lots of good pattern stuff there. Lots of examples of using patterns to implement concurrent and network software using the ACE frameworks and C++. Let's see, and so that's basically one place you can go to find all kinds of stuff on patterns. You can also go here. Let's go ahead and take a look at my website. Let's take a look at my digital learning link. So I have a thing on digital learning. If you go to my website, which you can easily find just by Googling me, and you click on MOOCs and digital learning, you'll come to this link. And this has a bunch of stuff with things on patterns and frameworks and so on. So I teach a class at Vanderbilt University on patterns, and you can find the videos for all those things here at my YouTube channel. I have a playlist with all my lectures on C++ and patterns, which was something I did last spring. There's lots and lots and lots and lots of stuff. There's probably about 25 hours worth of material there. If you happen to be a subscriber to the Safari Online Book Club book service, there's a nice set of material I put together describing design patterns in Java, which you can take a look at. And it basically has Java versions of many Gang of Four patterns. It's about 6 hours worth of videos on that. So if you're a Safari user, I recommend you take a look at that. There is also a Facebook page that's dedicated to this particular link. As you can see here, this is the Facebook page for design patterns in Java, and there's a bunch of discussions about various topics. There's about 800 people subscribed to that, so you're welcome to subscribe to that. Just as a little announcement, I'm going to be doing another live lesson offering for Pearson Education. I'll be filming it later this summer, and it's going to basically be concurrent programming in Android. So it'll be professional quality versions of a lot of the material we've covered in this MOOC, but done with state-of-the-art technology. All the things that annoy people, like you know, I'm on screen too long or whatever, that'll all be addressed. It should be much, much better. And I'll also be updating all the material to make it better as well. So those are some places you can go to find out lots more stuff about patterns. Let's see, Jet asked the question, will the course material be available for access after the course ends? Jet, of course, you should know by now that those kinds of questions are always answerable by going to the wiki page and looking at the POSA FAQ. Let's take a look for the word available. Hopefully I can find this quickly. Let's see. Somewhere it's in here. Let's see. This says this one just says that all the material for the 2013 version. Here we go. FAQ item number 26. How long will the course material be available online after the MOOC ends? And so basically we say here we're planning to keep it around in perpetuity, just like we've done for the POSA 1 version. So if you are doing some project and you go, gosh, if only I knew how to do bound services with the AIDL, but I can't remember how to do that, then you can go ahead and look at the course material. Of course, I should also point out, just because it's worth pointing out, something else. If you want to see the material, you're also welcome to view it from my YouTube channel. And you can see the POSA MOOC 2014 playlist is here. We now have about 12 hours worth of material up there. In fact, I have just got done uploading a bunch of videos that'll be part of the optional lectures from week number 10. And if you're curious, you can watch previews of them before they go live this Friday. We have some stuff on publisher-subscriber pattern in Android, the thread-specific storage pattern in Android, the active object pattern in Android, and the half-sync, half-async pattern in Android. So those are all additional videos that talk about various topics. I might also upload the asynchronous completion token pattern right up if I remember to do that. So all that stuff will be going live on Friday, but you can watch previews of it here on my website. Derek asks, is it a best practice to store the data the service gets from the web into a local database? So obviously it depends on what you're trying to do. If you are trying to build some kind of cache, then obviously you'd want to store it in a database using SQLite or something else like a file system or whatnot. SQLite is probably the most obvious way to do things. If it's just a simple pass-through, as it is in this case, then there may be no need to store it, but that's certainly something that you would want to do on a per service basis to decide why you would want to do it one way versus the other. I'm a Pluralsight subscriber. Paolo, I don't know what Pluralsight is, but I'll take a look at it. I don't have any plans to do anything there, but if it's interesting, it might be fun. Philippe asks, will there be an assignment related to week 9? No, there are no more assignments. We kind of pushed things to the limit already by kind of having assignments run over the actual endpoint of the class. But I thought, like I said before, you can skip a couple of assignments and still pass with distinction. And I figured people were probably interested in, some people would be interested in doing the assignments and getting feedback on the assignments. And so we ended up going a little bit later. But no, there will not be any more assignments for those. Although if you're interested, you can always take a look at my CS282 course. Let me go ahead and show you what I'm talking about here. And let's bring up a website and make it visible. Whoops. Oh, that was spectacularly weird. It's like infinite windows. There we go. Let's try to make that guy the one. That looks better. Okay, so if you go to, well, here, let's take a look at the fact. As in most things in life, in this class, you can usually learn them by reading the fact. So this says, what do you do if you find the assignments are too easy? So there are two things you can do if you find the assignments too easy. The first thing to do is just try to implement them without using the provided skeletons. So for everybody who complained and said we gave too much scaffolding code, well, the trivial solution to that problem is just basically take the activity and write these services and everything else yourself. You know, don't just ignore all the stuff that's provided, and then you can write it as much as you want from the ground up. The reason why we didn't make that the default is it would have been really, really, really hard to come up with a sensible rubric that people could have used to assess stuff, because everybody's solution would have been wildly different, and trying to come up with some way to evaluate the solution would have been hard. And for everybody who thinks that it's easy to write auto-graders for arbitrary implementations, go ahead and try, and you'll see very quickly why we didn't do that either. So anybody who thinks that's easy, give it a shot, and if you find it easy, let me know how you did it, because it takes a lot of work to do that. Also, if you're bored, you might go ahead and take a look at the assignments for my CS282 class, which was based on Android. And this is more the kind of stuff that we give here at Vanderbilt. And so if you look at the assignments, you'll see some of them look somewhat similar to what we've done. They have various image download kinds of things. And they give you much less help because they're meant to be written by people in our class. There's even a cool assignment number 6, which we didn't really ever get to cover this topic in the MOOC, is to use content providers to store the information. So if you're really bored and you want to do some more stuff, you know, take a look at these things. You're welcome to implement this. It actually would be fun for people to kind of crowdsource different peer assignments that wouldn't be actually part of the Coursera course, but could just be done entirely optionally by people who want to just have fun and then peer review each other's assignments. So Jet says he likes the optional video style. Yeah, that style is lots of fun. Those are just me standing in front of my class with the camera rolling, just giving my lectures. We didn't use that as the style for the bulk of the MOOC for several reasons, even though it's a good style in many ways. Number one, that's even though those lectures look easy, it takes an enormous amount of effort to prepare to give them, number one. And the problem is when they're done that way with no script, then unfortunately it's very hard to repurpose pieces of the lecture. If there are mistakes in the lecture, which there inevitably are, it's very hard to go in and just reshoot one piece of it without having to go redo the whole thing. So it's not a very practical way to build up course material in general, but it is a lot of fun. And what I do when I teach my classes at Vanderbilt, I either record them with a camera or I just do a screencast, and I put them up on my YouTube playlists. So this class, for example, the MOOC that we're doing this time, will be offered again, or I'll be offering it in my Vanderbilt class in the fall. And so anybody who is interested in seeing what I do with the subsequent versions of this material is welcome to follow along. I'll be posting the lectures, most probably in screencast form, on my YouTube playlist, so you can kind of see it in a more conversational mode. And then what I'm going to do is I'm going to take the results of those things and basically reverse engineer the next set of material for the next MOOC. So hopefully over time the material will get fleshed out and more complete and more comprehensive. But you know, there are pros and cons to each approach. Having things tightly scripted makes it much to reuse the material in bits and pieces for all kinds of other purposes, which is really the goal of all this. Let's see. Post a link on your Google Plus page to your new summer course. So Sheila, I'm not sure which course you're referring to. The next course, the next MOOC in this sequence, of course, is going to be the mobile cloud computing with Android course, which starts in a couple weeks. Professor White will be doing the bulk of that course. I'll be doing a little bit of stuff, but he's the basic person. I'll talk more about that in a second. The course I'll be teaching at Vanderbilt this fall will start in late August. And as I mentioned before, we will create a YouTube playlist for that, and all the videos that I record will go up on that playlist. And so the easiest way to find out about that is just to subscribe to my YouTube channel, and then as those videos get posted, you'll be automatically notified, and you can go and take a look at them. Are there any other courses we'll be doing this year? So we're going to be doing the cloud course. In fact, let me go over and show the cloud course real quick while we're discussing the cloud course. Here is the cloud course. Let's see. I think this is probably available now to people who subscribe. We asked for them to make the course site live, even though there's not a whole lot of stuff in there yet. So if you go, for example, if you can get to the course, you can also see this from the front page also of the course. Here's the syllabus for the course. As we mentioned before, the course is 10 weeks in duration, but there's really only 6 weeks of mandatory material, and this is intentional. We're trying to give people flexibility so they don't have to spend their entire summer chained to their computer doing MOOC material. And the first 6 weeks, which are what's shown here in the syllabus, is basically Jules White presenting his material on mobile cloud computing. And all that material has been posted to YouTube. So if you go to, see if he posted this on the course announcements page. Whoops, he hasn't posted that on this announcements page, but I think it's on the other one. Let's see. Go over here to the POSA announcements page. Preview videos for the Programming Cloud Services course are available on YouTube. So if you go here, you'll hear the familiar music. And Jules has posted all 6 weeks of his course, or previews of all 6 weeks of his course material on YouTube, so you can start to look at it if you want to. As always, it's likely that some of it may change, but that's a good starting point. So that's the first 6 weeks, and that's all going to be web services and Java and cloud computing and so on. You can see all the topics that will be covered. And then we also have 4 weeks of optional material, which are basically going to be patterns and frameworks for concurrent and network server-side software development. And this is basically the material that covers patterns from the POSA 2 book, using a web server as a case study. This is using ACE and C++. I think we're going to have quizified videos. It looks like we'll be able to do that. We'll probably also have some optional assignments there for people who want to have fun and peer evaluate each other. That's not required. When we did the course last year, the POSA course version 1 last year, we let people write the solutions in whatever language they wanted. They could do it in C++ or Java or Python or Ruby or Objective-C. And then we had peer-graded assignments for people who wanted to peer-grade each other's solutions in those languages, which worked out pretty well. People had a lot of fun implementing all the different patterns in their favorite language and their favorite frameworks. And so that's also what we'll be covering. So I'll be sort of involved with that. And then, of course, the next thing we're going to do after all of that is we're going to have the capstone. For those of you who are on the signature track and who pass with distinction, there'll be a capstone project that you can do. We're working through the details of that right now. It looks like a pretty cool set of things we're going to do. We're going to have at least one assignment that we create that students can then use, and then we're probably, knock on wood, going to be getting other programming specifications by companies like Amazon or Google or Facebook or whomever, and they will provide the specifications, and they will hopefully provide people to provide help for those specifications, so students can choose one of, from 3 or 4 different projects. And we're intentionally making the specifications fairly generic and fairly underspecified. And the idea there is we want to give enough structure so people know what they need to do, so we can evaluate the various solutions, but we want to leave lots and lots of room for creativity for people to add stuff above and beyond what's in the spec. So it looks like we're going to have at least one assignment where people will come up with a way of being able to sort of upload images and text to a cloud server on various topics, and then they'll be able to sort of upvote the material, and they'll be able to query it according to several different criteria, and access it and manipulate it in various ways. So that's kind of the bare bones approach that we'll have. But then people can take this in all kinds of other different directions, and you could gamify it. You could turn it into a mobile health application. You could turn it into a nutrition application. You could do some version of like Snapchat or Instagram or Twitter or whatever. So you're going to get a chance to play around with user-facing capabilities in the Capstone project, service implementation on the phone, as well as service implementation in the cloud. And we'll hopefully have a bunch of different ones. So that'll be starting in the October timeframe, although we may release the specification early for people who want to get a head start. Let's see, Craig just asked about the project will be used in the Capstone project course. So like I said, we're going to have a project there that is all about uploading and querying information, multimedia information in the cloud. And people can go all kinds of crazy enhancements. Like, for example, one thing you could do is you could set it up so you could query based on location information. You could say, find me all the information that's near me, and give it a region or your current location within a radius number of miles. So we're going to make it interesting so people can go and above and beyond the original spec. Will we have a chance to gain access to some part of the Capstone projects? Philippe, that's a good question. I don't see any reason why not. In fact, if it was entirely up to me, what I would do is probably release the Capstone projects in an open way, and then there would be one version of the course that would be done for people who'd passed all the requirements. They'd gotten a capstone they'd done the signature track for the other 3 MOOCs with distinction, and we would then help them and shepherd them. But it would be fun if we built like a complete crowdsourced version, a community-based version, where anybody who wanted to just have fun and play along could do the Capstone project also. We, the instructors, probably wouldn't provide any help for that because that's not officially part of what the Capstone is, but people could do it by some kind of community model. So I see no reason not to do that, but I'm not the one who calls that, who makes those decisions. But it would certainly be fun to do something like that, get more people involved. With the REST API, it's possible to completely decouple the client and the server implementations, which is cool. Yes, I completely agree. Let's see. Any plans to put a summary video that frames up everything that we've learned in this course? Well, maybe we can do that next week. So we'll have our 10th and final, no, 10th, 9th and final virtual office hours next week, probably on Wednesday, probably the same time. And if anybody has any questions, if they'd like to go back and kind of revisit stuff, I'd be happy to do that. I'd be happy to sort of walk through the syllabus and talk about things that we've learned. If I'm extremely productive, I may try to shoot one more video that kind of walks through the acronym application like I just did, except do it in a nice, more production-oriented way, and kind of talk about that as an example of programming bound services that access web services using AIDL, because I think it's a very, very cool topic, and the example is something that you could reuse for all kinds of other purposes if you so desire. Let's see. Dinakar, is it okay to add you to my Google Circle? Sure, not a problem at all. All right, the very, very last thing I want to do here, unless there are any more questions, is I want to go ahead and see if there's anything that came in on the discussion forum that I need to answer before we wrap up. So let's go ahead and go to POSA forum. Hopefully you can see this. I think so, yep. Go to virtual office hours. Go to week 8 virtual office hours, and let's see what questions we have here. All right. Let's start with Lydell's philosophical question. He asked a very interesting question. He basically is asking, would it have been possible to make it easier to write services that cross process boundaries without requiring the use of AIDL? And the answer is absolutely yes. You certainly, or the Android developers certainly could have done that. In fact, they could probably also have written a version of the broker implementation that isn't quite as obtrusive and quirky as the one that they defined. The binder and AIDL stuff is a little quirky, and it kind of intrudes into your application in some ways that are a little bit funky, like the on-service connection stuff is a little funky and so on, which is why we wrote that generic service connection helper framework that we talked about with the acronym application. So they certainly could have done that. In fact, they could have even gone one step further and probably hidden everything from you, so you could have just written Java code and had it all just kind of work magically behind the scenes. Why didn't they do that? Well, there's a couple reasons. One reason they didn't go with a more transparent broker like Java RMI or Java or C++11 bindings even for Corba is probably because it wouldn't have fit in well with the kind of callback-driven model that is otherwise pervasive throughout Android. So if you look at Android, pretty much everything is driven by asynchronous event callbacks. All the lifecycle methods for activities, all the lifecycle methods for services, and other kinds of things. It's all driven by callbacks. And so making things sort of this synchronous broker-like model probably would have been contrary to their asynchronous model. And that asynchronous model is very important because they're trying to keep the UI thread from blocking for any period of time. So that's sort of one thing, one reason. The other reason, of course, is if you the more transparent you make things, the more overhead there is, because you have to rely on language features like reflection or introspection and so on. And you can make your code more transparent, but then there's also more overhead. And so there's this continual trade-off between ease of use versus performance. So that's another reason why they kind of went the way they did, because the AIDL implementation is fairly thin and lightweight and doesn't really add a whole lot of extra overhead to anything. And even though it takes a little bit more time to learn to program at first, it's not very hard, and it's used extensively throughout Android. There's hundreds and hundreds of AIDL interfaces throughout the Android frameworks and packages. But ultimately, I think the reason that they did what they did is explained in this interview with Diane Hackborn, who's one of the Google infrastructure middleware developers. By the way, what a cool name for a software developer, Diane Hackborn. It's like sort of almost sounds like a movie name, because you're like born to hack. But she worked on the BOS, and I think that the open binder framework that they used on BOS is what they basically morphed into the binder framework for Android. So I think they were just familiar with the patterns, the APIs, the programming style, and so on. So yeah, they certainly could have done it in a different way, but what they did is really not all that hard to learn. And in fact, once you get used to it, you'd probably be crazy to do a lot of other things with messengers for anything other than really trivial kinds of applications. Let's see, downloading XML data. So I gave a Stack Overflow link that talks about how you can make calls to async task within the on-post-execute method of async task. I think that should be fine. Jasky asked the questions about the Android permission attribute. I'm going to let Jules answer that one, because that's his baby. He's the security guy, not me. Let's see. Here's a question. This is sort of a brand new question from Guillermo. Trying to access a web service that can take a lot of time to respond using Android service and AIDL. Is it possible to create a service call using a timeout, or must the service always respond? So I'm assuming by the word service here is a little bit ambiguous, because you have a web service and an Android bound service, or actually you could use a started service too. So I believe it's the case that a two-way call on a service will block. So you probably don't want to do a two-way call. In my estimation, two-way calls are somewhat problematic, or very problematic in Android for a whole bunch of reasons. So I'm much more of a fan of doing one-way calls. So you could certainly do one-way calls, and then it wouldn't matter if it took a very long amount of time for the response to come back, or you eventually got tired. You could simply have the service, send back something saying the call has timed out. Right? That's not a problem to do that. So that would be probably the easiest way to do it. Of course, if you're making a web service call, you can in fact time those out using various timeout operations that you can define in various options on the web invocation interfaces. So my preference is to use asynchronous AIDL for this kind of stuff, and then it becomes really simple to do all these kinds of different timeouts and so on, because you're not blocked waiting synchronously in the first place. There's also a question about using services and async tasks and threads and so on and so forth. And so all of this stuff is described in great detail in the various lectures. If you take a look at the lecture video on programming the Android concurrency frameworks, both part 1 and part 2, they show how to use various forms of runnables and messages and async tasks to be able to do concurrent operations. If you take a look at the various examples from the services videos, programming bound service or programming unbound services, or sorry, programming started services, and overview ADL, you'll see how to do the services stuff. So all those things can basically be done. Generally, the specific question is you really shouldn't be using an async task within a service. I think you might be able to get away with it. I don't know whether the system will crash on you, but you really should be careful. I mean, it'd be fun. You could easily try it out and see if it works, but it's not a good practice to get into. And there's all kinds of other ways to write concurrent services, ranging from using the async task mechanism, ranging from using the intent service mechanism to using the executor service with thread pools to using all kinds of other things as well. So it's pretty easy to do different kinds of mechanisms here. All right, let's see. I think there's a last question. Let's see. Virtual office hours. All right, so I didn't upload these videos. These are Jules' videos. Those are all the ones that, so that all the videos that Jules has done, which basically correspond to what's in the course, are already uploaded to his YouTube channel. So you can certainly go there. And if you want to see the videos that I will be presenting, by some definition of presenting, just go back to the POSA 2013 POSA course, and you'll see all the material in section 3 are the videos that we'll be presenting from the part that's the optional part. So you can download all that stuff. They're even quizified, so you can even watch the quizzes if you want. You can even do the quizzes if you want, and it's got all the links and so on. So it should be easy to get access to all that information. So yes, all the videos are available. You can watch all the ones you want. That isn't to say that we won't add a few more at some point, but this should be more than enough to keep you going for the time being. All right, well, I think that is probably it for this week. If you have any other questions, don't hesitate to post them. As I mentioned before, Professor White has recorded a video with him going through his solution to week 7 assignment 6, and he'll be posting that as soon as he gets access to the internet. He's kind of off the grid this week, but he periodically gets access to the internet, so I think he's going to go ahead and upload that when he has a chance. And then he also said he'd be happy to answer questions people post on the discussion forum. So if you have questions about grading, for example, go ahead and post those. You might as well post them in the week 8 office hours, just because that's a good place to put them. So with that, I think we're basically done for today. As always, as soon as the video is finished being produced by Google, by YouTube, I will download it and post-produce it and upload it, and you'll get a chance to watch it either later tonight or early tomorrow. Thanks again very much for joining, and I will look forward to seeing you again soon.